Welcome to my session, Architecture of DevOps. Now you maybe want to ask me, what has architecture to do with DevOps? Because often when we're talking about DevOps, we're talking about things like culture, bringing people together, and about delivering value. If we don't talk about CI/CD, that was DevOps. But DevOps is so much more than that. This or similar pictures is something that we often see when we're talking about DevOps. It's often called the DevOps loop or the feedback loop. It shows every phase from planning, coding, testing, deploying and releasing to operate and monitoring an application in production. And we will iterate that continuously. I would say that we not can have an application that are in maintenance when we are talking about DevOps. Maintenance and DevOps cannot coexist. With DevOps, we will continue to develop an application for the whole life of it. Of course, we can do that in different speed with different amount of developers working, but if we put the maintenance in a classic mode, it's more or less dead. But if we break down this DevOps loop to a simplified image, we will get the core concepts about DevOps. It's to build, measure, and learn. And all with one purpose, to deliver value to the user. And deliver value continuously. But what we don't talk much about is how to build our application so we can deliver value continuously. And that's why I am here today. I will talk about the architecture of DevOps. My name is Daniel Hindrikes. I'm working here at the tretton37 office in Borlänge, mostly with the mobile and cloud solution powered by Xamarin and Azure. And if you want to learn more about Xamarin, you can read the book that I wrote together with my colleague Johan Karlsson. He's not here today, but he's also working here at tretton37 Borlänge. To understand why we need a DevOps culture, we need to understand some of the problems we have when we are developing applications. When I say developing, I don't just mean when writing the code. I mean everything the development team are doing. So instead of developers, we're talking about development team. Okay, we will of course talk about code during this session. But we will start to talk about deployments and installation. An easy way to deploy is maybe one of the most important things when we want to deliver value continuously. And that is probably why many people is talking about CI/CD, continuous integration and continuous delivery, when they are talking about DevOps. So let's talk a little bit about that, continuous integration, continuous delivery. Why do we need that? According to me, there are two main reasons. Number one, to ensure quality. Even if we don't deploy all builds, there are a lot of winning by having a CI build. We can ensure that we don't break others' code, but we can also build for other configuration platforms that we maybe not are doing on our local machine. Of course, that depends on what type of application we are building. If we have, for example, mobile devices, we maybe want to compile for iOS, we need to compile that on a Mac, and we are doing our daily development on a Windows machine. And then we can verify that it works even on a Mac before we commit it to the master branch. So that's how I work as a mobile developer. But we can also add different tests, unit testing, UI testing, so we can verify that everything, not everything, because it's impossible to test everything before we merge to the master branch. But if we work with pull requests, we're doing quality checks, we can ensure that we have much better quality before we're merging. And that means that when we have merged it to the master branch, we are ready to deploy it. At least we are ready to deploy it to a test environment. But we also will compile a build that we can use to deploy to the production environment. As a user, we hate messages like this. Even if we're building an application for internal use, it's really important the user can use the application without downtime. You don't want your application to be the application that every user hates, as with 99% of all time reporting applications. If you will get an example, we want to build an application that have high acceptance by the user. Okay, for an internal system, it's maybe more about user acceptance because it's not a really big deal if the system is down an hour a week. But if we're, for example, building an e-commerce site, every second that the site is down, we will lose money. If we have a unique product that no one else is selling, they maybe will come back to us, but if not, they will probably buy it from some other sites instead. That's why it's so important that the public website needs to be up 24/7. I want to tell you a true story about one project that I have worked with, where we have a lot of problems and downtime every time we want to do a release. Do you think we released often? No, we didn't. Maybe a couple times every year, or even less. But this was a couple of years ago. I joined the project. It was a pretty big project. As most, we were around 20 developers, and we worked with a platform that have about 10 different applications, maybe more. I don't remember. But we have automated builds, automated deployments, but just for our development environment. When we want to deploy to an environment that our customer could test and interact with, we need to send our application package to the operations guys. But before we could do that and they could do the job, the product owner had to communicate that this platform should be down for at least 1 day. And we have to write instructions how they should deploy it. You have a question?
Yep.
Huh? You raise your hand. Yeah, we had to write instructions, and of course they had to read it. And often they didn't read all of the instructions, so there were a lot of problems to doing these deploys. They probably don't think that our instructions was good, or they thought that they didn't need that. But this often resulted in that a deployment to this platform or the application, or maybe just one of the applications, took often longer than 1 day. So that means the user could not work their primary work tools for more than 1 day. It's like we should sit there and we cannot use Visual Studio for 1 whole day. We cannot work. At least we cannot produce anything. Think instead if you have had an automated process for deploy. You should have been sure that all steps were down the same way in all environments without the risk for humans' mistakes. Because humans make mistakes. But it's not that simple. Automated process will not fix everything. It will make it easier to deploy. But there will still be risks to deploy a platform like this. Especially when there are a lot of dependencies between the applications. This is a simplified overview of the platform. Not all applications and dependencies are included because there were a lot of different Windows services and other stuff. But it was too complex to include everything here, and it had just been lines everywhere. But you can see already now it's really complex. If you want to change something, for example, in the billing system, we often needed to do changes in the customer application as well, because it was will be hard dependencies, and changes in customer application also affected all the other application. So what happened was that we was not able to update a single part of the platform with taking all applications down. But do we need to build our applications like that? Of course not. And if you want to work with DevOps for real, we cannot build up our application this way, because it's more or less impossible to deliver value continuously to the user. In the best case, we can deliver a couple of releases every year. Microservice architecture is very popular and hot right now. And if you do it right, it will solve one of our problems, but you have to do it right. If you're doing it wrong with microservices, it will probably be even more complex. I will not go deep into microservices and how to build them, but I will talk about how they can solve our problem. The key is to remove as many hard dependencies as possible and make the application more platform and more asynchronous. In this picture, we have two applications, two front-end applications, so you can say that this is two different websites. Both application A and application B is working with customer data. Application A only needs to show data about customer. And in application B, we can also edit the customer data. The first thing that I should do in this case is to add a service bus that we can put changes in. So when the user makes a change in application B, instead of calling an API directly that saves it to the database, we put the change in a service bus queue. And there can be different type of service buses. I prefer to have the topic subscriber model, because if we have that, more than one listener can get the updates. If we have queue, it will be processed, and the first one that reads the message will also remove the item from the queue. And the topic subscribe model also ensure that all subscribers will get the message, even if they are down when the message is sent. So to the service bus we'll add, for example, an Azure function, but it don't have to be an Azure function, but we can say a listener that process the messages from the service bus, and it will put it in a database and save it there. So this makes it possible to change the code, how we handle the data, how the data will be saved in the database without affecting the front-end application. But if we want both of those applications to read the data, the easiest way, both for performance and to not have any dependency, is to add a cache to that one. So we add another function that will populate the cache, and that function can also listen to the service bus, so you don't have to read updates from the database. But we can also have that function to rebuild the cache, maybe every night, to ensure that everything is right in it. So this means that we can, even if everything here in the behind the cache goes down, and we can work with it, update it, both applications can still read the data from the cache. The worst thing that happens is that they have a little bit old data, but users can still use the application. So in most cases, there are no problem that the data is a couple of minutes old. And when we have a service bus and the topic subscriber model, is even very easy to add more listeners to this. We can say, for example, this is a customer microservice that we have now. But if we want other services to consume the data, it's easy to just add a new listener to the service bus. For example, we can have an analytics service that wants to know things about customers. They can just listen to the service bus. So what about code quality? Well, we're talking about delivering fast, delivering often. In many cases, code quality is not important. At least the developers and the team don't think it's important. It's more important to deliver value. But if you ask me, I think it's hard to deliver value over time without having good code quality. That means that it is really important to work with code reviews, unit tests, and also have many rules how you should code, and let the team follow them. And to do that, we can add a lot of different things. We can add, for example, static code analytics, so you can know if you break any rules. If you're writing complex code, for example, there are a lot of different tools. In Visual Studio, you have independent, things like that. You can add them to your CI/CD pipelines. And of course, I think every developer should run those tools before they're creating a pull request. And I also think that we should add tests, and we should work with a test-driven development, or at least we should write unit tests after that we have written code, at least for our most important business logic. I don't think it's important to have 100% code coverage, but to have unit tests that covers the most important part will help us to deliver value over time and deliver good value over time. And I also said that before, I also prefer to run UI tests, and that the developer that makes changes is the responsible that the UI tests works after they have made changes, because that helps, and it will be a shorter process. It will be not that many bugs that goes to the quality assurance environment, test environment, or what you like to call them. Of course, that can feel time-consuming, but I can promise you, in the long run, it is worth it. But even if we had a good process for quality assurance, it's hard to know how applications will behave when they are used by real users. So I would say a definition of done is when a feature is tested and measured in production. That means that you need to build your application to have good analytics. Of course, you need to track errors, but you can also track a lot of other different things in your application to see how it reacts when a real user is using it. Because they probably use it in another way than we do, so we have a build application. But even if we work hard to ensure quality before a release to production, it sometimes goes wrong. Maybe because that we have other data, user, or other dependencies in production. So then we need to handle that situation. Then we can have a couple of options. We can do a rollback. But if you decide to do that, I hope that you have a good architecture that makes it possible to just roll back the part of the application that you will have the problem in. Because if you should roll back a big system like this that you talked about earlier, it will take a lot of time. If you have done a database restore, you know that takes time. So in many cases, I think there are a better approach. You can instead just go and fix the error. You maybe just have to run a short SQL script that will update a column in the database, and that will fix a problem. It will take a couple of minutes instead of just doing a rollback. But even but if we're talking about websites, APIs, it's probably easier to do rollback, and especially if we're using a cloud solution, Azure, for example. They have something that they call slots, so you can deploy to a test slot on your development environment before, and you can easily switch them. And you can also say that try this new code for 20% of all the traffic. And then you can increase that amount after time. So the next day you maybe have 50% of your code goes to the new of your traffic going to the new code. But that requires that you don't have breaking database changes between these changes. So, but it's a really easy way to ensure quality before you're rolling out your changes to a big amount of users. And if you're developing mobile apps, you can also do this, cause stage rollouts in Google Play and Apple App Store. It's a release in Apple App Store. You can say roll out these changes during 7 days, and there will follow Apple's algorithm how to roll out that. It's just a few users the first days, and it will increase. For Google Play, you can say manually, as with the slots, how many of the users that will get the changes. So, for example, we can have a small amount of users the first days, and it will increase and roll out to more users faster after a few days. Do you remember when I show this one in the beginning? There was some struggle with the project or the cables here. But here is the image. It sounds simple. Of course, we have to think about what we want to measure, and probably we have a business analyst that will be a part of that process as well. But what I want to say is that we need to build our application in a way. I talked a little bit about this earlier also, but we need to build them in a way so we can measure. And if we do stage rollouts, we have a really good moment to measure and how the real users are using it before we rolling out changes to every customer. Another thing that we can measure and how we can work is that we can use something called feature flags. Instead of just say an amount of user traffic will go to this new change, we can add feature flags to our applications, so we can turn it on from a configuration tool. So we can say turn this new feature on for this group, and we can measure how they use it, if they will get an error. So that's another approach to do a form of stage rollouts. We can also use that for testing, A/B testing, if a user likes a new feature, if it's what we should work more on, for example. So I think feature flags is something that we could use much more than we are doing in application. It's also easier to roll out new changes, for example, in an app that requires Apple to review the application before a release. Then we can prepare the code, we can submit it to Apple, and when we are ready and the marketing team, for example, is ready, we can just enable the feature by a configuration flag without to have to send it back to Apple or Google for review before we roll it out. If you have used Azure DevOps, you have probably seen how they're using feature flags. They want you to opt into it. And if you opt into a feature, a preview feature, it's easy to ask the user for feedback as well, because they know that they are in a preview program, and they are often open to give feedback, and they know that things will probably not work perfect before it's leave the preview. So why do we fail with DevOps? There are a couple of reasons to that. So this will be more of a summarization of what I've talked about. So bad architecture is really important. I've often been in projects where architecture is something one person will get a few hours in the beginning of a project for. But I think it's really important that we have an architect during the whole project, because there are always things that coming up that we need architecture input for. It is really easy that we otherwise select the easiest route, the route that was the easiest for the moment, but maybe not the best in the long run. So one big DevOps team we often talk about one big DevOps team where all users can do everything. But I don't think that is the case with DevOps. Everyone in the team should not be able to do everything, but the team together should be able to do everything. So that's important. Another thing that is often makes us fail with DevOps is that we have a complicated deploy process. I talked about that earlier, and it's not just that it's hard to do releases, because if we do releases and we are failing, we became afraid to do releases because we just want to test more, we just need to code more, test more, and so on. And we'll never do releases. But if we have a process that we trust and we do successful releases without big bugs, of course there will always be bugs in our applications, but we don't want to have that much errors and downtime when we're doing a new release. Another thing is that we have insufficient quality assurance, because if we don't do quality assurance in a good way, we will have the same result as we have a complicated deploy process. We will not do releases, or we will do releases often and we will lose customers because our application have a lot of errors. So, to summarize this, architecture is important, code quality is important, test is important, quality assurance is important. I think that is 3 points that makes it easier to success when we working as a DevOps team and we want to deliver value continuously to the user. I had a fourth point there as well. Automated process is important, of course. That was all from me today. If you have any questions, you're welcome to ask me them now or stay here and ask me them later. Or you can contact me on social media, for example. Thank you.